What if I told you that there are entire forests at the bottom of the ocean that are older than human civilization? Trees that survived the Ice Age and have been waiting underwater for over 60,000 years to tell their story. Welcome back to Beneath the Depths. Today we're exploring one of the most incredible discoveries in marine science, ancient forests that have been perfectly preserved on the ocean floor, creating time capsules that are revolutionizing our understanding of Earth's past. Off the coasts of Alabama, North Carolina, and other locations around the world, scientists have discovered something extraordinary: complete forests lying on the ocean floor. But these aren't recent casualties of coastal erosion or modern environmental disasters. These are ancient woodlands that date back tens of thousands of years, some even predating the last ice age by incredible margins. During the last ice age, which ended approximately 12,000 years ago, sea levels were dramatically lower than they are today, sometimes by 400 feet or more. What is now ocean floor was once dry land covered in vast forests of cypress, oak, and pine trees. These weren't small groves or scattered woodlands, but massive forests that stretched for hundreds of miles across what would eventually become the continental shelf. As the massive ice sheets that covered much of North America and Europe began to melt, sea levels rose gradually over thousands of years. These forests were slowly submerged and buried under layers of sediment, creating natural time capsules that have remained virtually untouched for millennia. The gradual nature of this submersion meant that many trees were buried while still standing upright, preserving entire forest ecosystems in their original positions. Here's what makes this discovery so remarkable. The lack of oxygen under the sediment created perfect preservation conditions. These trees are so well preserved that scientists can still see the individual rings in the wood, analyze their cellular structure, and even identify the exact species after 60,000 years underwater. It's as if these forests were frozen in time, waiting for modern science to uncover their secrets. These underwater forests are like biological libraries, storing an incredible amount of information about ancient climates, atmospheric conditions, and ecosystems that existed long before human recorded history began. By studying the tree rings, scientists can reconstruct detailed records of rainfall patterns, temperature changes, drought cycles, and even major storm events from tens of thousands of years ago. Each ring tells a story of seasonal changes, environmental stresses, and climate variations that occurred during some of the most dramatic periods in Earth's recent geological history. The preservation is so complete that scientists can extract and analyze pollen grains, insect remains, and even DNA from these ancient trees. This provides an unprecedented window into prehistoric ecosystems, allowing researchers to understand how plant and animal communities responded to major climate changes in the past. But the story doesn't end with preservation and scientific research. These ancient forests have become the foundation for entirely new ecosystems that exist nowhere else on Earth. The preserved wood provides habitat for unique communities of marine life, including rare species of shipworms, specialized bacteria, and other organisms that have adapted specifically to this ancient wood environment. These creatures have evolved to feed on and live within wood that's thousands of years old, creating symbiotic relationships that have developed over millennia. Some of the organisms found in these underwater forests are completely new to science, representing evolutionary pathways that took thousands of years to develop. Marine biologists have discovered species of bacteria that can break down ancient wood compounds, tiny crustaceans that live exclusively in the hollows of prehistoric trees, and fish species that use the ancient root systems as nurseries for their young. Researchers are using these forests to understand how rapidly climate can change, what happened during major climate transitions, and how ecosystems respond to dramatic sea level changes. This information is crucial for understanding current climate change patterns and predicting future environmental changes. The data extracted from these underwater time capsules provides baseline information about natural climate variability that extends far beyond human record keeping. The research has revealed that climate change in the past happened much more rapidly than previously thought, with some transitions occurring over just a few decades rather than centuries. This has important implications for understanding how quickly current climate changes might accelerate and what impacts we might expect in the near future. Unfortunately, once these forests are exposed to oxygen-rich seawater through natural erosion or human disturbance, they begin to deteriorate rapidly. Scientists are racing against time to study and preserve samples before this irreplaceable record of Earth's history is lost forever. The race is particularly urgent because coastal development, offshore drilling, and deep-sea fishing activities pose increasing threats to these underwater archaeological sites. Some preservation efforts involve creating detailed, three-dimensional maps of entire forest sections before they deteriorate, while other projects focus on extracting and preserving the most scientifically valuable specimens in controlled laboratory environments. Advanced underwater robotics and scanning technology allow scientists to create virtual reconstructions of these ancient forests, preserving their structure digitally even after the physical remains have decomposed. The technological challenges of studying these underwater forests are immense. Scientists must work at depths where human divers cannot safely operate, using sophisticated remotely operated vehicles equipped with specialized sampling tools, high-resolution cameras, and precision cutting instruments. The pressure at these depths can crush ordinary equipment, requiring specially designed chambers and collection systems that can function under extreme conditions. One of the most remarkable aspects of these discoveries is how they're changing our understanding of prehistoric human migration and settlement patterns. Some of these submerged forests existed during times when early humans were spreading across continents, and the coastlines where these people lived are now hundreds of feet underwater. Archaeological evidence suggests that some of the richest hunting and gathering grounds of prehistoric humans are now buried beneath layers of sediment on the continental shelf. Advanced carbon dating techniques have revealed that different sections of these underwater forests span enormous time periods, creating layered records of environmental change that extend back much further than any other source of climate data. Some tree specimens have been dated to over 100,000 years old, providing glimpses into climate conditions that existed during multiple ice ages and warm periods. The chemical analysis of these ancient trees is revealing surprising details about atmospheric composition during prehistoric times. Scientists can measure the levels of carbon dioxide, methane, and other greenhouse gases that were absorbed by the trees during their lifetimes, creating a detailed record of atmospheric changes that occurred long before human industrial activity began affecting global climate. Marine archaeologists working on these sites have discovered that the preserved forests often contain artifacts and evidence of human activity from thousands of years ago. Stone tools, pottery fragments, and other archaeological materials have been found embedded in the sediment layers around these ancient trees, suggesting that early human settlements existed in these areas before they were submerged by rising sea levels. The international scientific collaboration required to study these underwater forests involves researchers from dozens of countries, sharing expensive deep-sea research equipment and coordinating complex expeditions that can cost millions of dollars. The logistics of working at such depths require specialized research vessels, support teams, and months of careful planning for each sampling expedition. Recent discoveries have revealed that some of these underwater forests contain trees that were still alive when they were first submerged, meaning they continued growing underwater for potentially hundreds of years before finally succumbing to the marine environment. This creates unique tree ring patterns that record the transition from terrestrial to marine conditions, providing unprecedented data about how forest ecosystems respond to gradual environmental change. The study of these ancient forests is also contributing to our understanding of how modern forests might respond to rapid climate change. By examining how prehistoric trees adapted to changing conditions over centuries and millennia, scientists can develop better models for predicting how current forest ecosystems will respond to warming temperatures, changing precipitation patterns, and rising sea levels. Similar discoveries are being made around the world, from the North Sea to the Black Sea, from the Mediterranean to the Pacific coast, and even in the Arctic Ocean, where melting ice is revealing previously inaccessible underwater archaeological sites. Each location provides unique insights into different climate zones and time periods, revealing that these underwater time capsules are more common than previously thought and represent a global phenomenon rather than isolated occurrences. The economic implications of these discoveries extend beyond pure scientific research. The techniques developed for studying underwater forests are being adapted for offshore engineering projects, underwater archaeology in other contexts, and even the search for shipwrecks and other submerged cultural heritage sites. The deep-sea exploration technology pioneered for these forest studies is contributing to advances in underwater robotics, marine geology, and ocean engineering. These underwater forests remind us that the ocean floor is not just sand and rock. It's a vast museum of Earth's history, holding secrets that span tens of thousands of years and containing information that could be crucial for understanding how our planet's climate system operates over long time scales. Every discovery like this helps us understand not just where we've been, but where we might be heading as our climate continues to change and sea levels continue to rise. The preservation of these sites has become a race against time, as increasing human activity in coastal waters threatens these irreplaceable scientific resources. Deep-sea fishing, offshore energy development, and underwater cable installation all pose risks to these ancient forests, making their study and documentation more urgent than ever before. What other ancient secrets do you think are waiting to be discovered on the ocean floor? Could there be entire prehistoric civilizations buried beneath the waves, waiting for the right technology to uncover their stories? Share your thoughts in the comments and subscribe for more incredible deep-sea discoveries that are rewriting the history of our planet.